manager of the database. And that is me right there. Today I'm going to be talking about one of my favorite topics, which is database indexes. I am very passionate about it. I've given this webcast a couple times before, and I've even talked about this in other webcasts that cover different subjects. So let's start out. I'm going to be separating myth from reality when it comes to if you're doing DBA work. Some DBAs don't know all of this stuff. If you're a developer, and even some application users. Try to dispel some of the misconceptions people have about what indexes are and what they can actually do for you and how it interacts with the application. Real quick, wanted to tell everybody about this really cool free tool. If you don't know about it, it's called SQL Developer. It's free from Oracle. Just download it from there, and you can pretty much manage an Oracle database using SQL Developer. That is a developer to SQL Server and even DB2, not iSeries, and a couple other databases. I have a video that shows how to install it. It is pretty straightforward. You may not need to watch that, but I have that out there anyway. So the application of the day, as it usually is Oracle's JDE Edwards product. JDE Edwards, as most of you are using that right now, it can run on Oracle, SQL Server, DB2 400, DB2 UDB, and because of how it's designed, it has a very unique way of running and using the database. So it's a great example to use even for just generic database webcasts that I do. So this another good factor is that the database is like not really mentioned in the documentation very much anywhere. So there's not a lot of insight into how the database might work with the application. They make a lot of assumptions, and JDE Edwards has some built-in tools that manage parts of the database that kind of make these myths and things, it kind of makes them even more believable because of how the tools work. So let's go in there. Let's go ahead with the first thing. What is the one crazy fact about indexes? Is that at runtime, especially with JDE Edwards, there is no relationship with what's inside the application and what's on the database. This is especially true with JDE Edwards. Even if you added an index with the JDE tool and used it as the basis of a query in your application, there's no guarantee that the database even cares about it. And there's no connection at all. So if you're in developing an app and it says, hey, you need to have an index that matches this fetch, and you put it in there and then they generate it, it may not matter. It may actually make things worse. That's not to say that there's no application in the world that can brute force the database into using a specific index. It's not that common to do, and if you second guess the database optimizer, you may end up with some crazy results. But let's take a step back. I don't know how many people know what an index is. I mean, you probably heard the word, but what is an index and why would you need one? To use a real world example, there's this giant warehouse here in this picture, and I want you to go and find me a football in this warehouse amongst all this stuff. And how long, if I just were to send you out into this warehouse, how long would it take to go through all of these racks and things to find one football? Probably a year? I don't know. I mean, you don't have any instructions, right? So what would you need to have in order to find that one football, or maybe find all the footballs in this warehouse? They could be spread apart anywhere. What would you need? You need probably a map, right? And a map is really a simple form of an index. This is a store map for the local Texas grocery store called HEB. It's not really super detailed. It's not going to tell you exactly what shelf something's on, but it's going to direct you to the right place. You want a bottle of wine, you go to the wine side. You want to get some frozen chicken, go to the frozen meat part of the store. And that's what an index does, is it shortens the amount of time it takes for you to get what you want from the database. Now, a database index is a little more complicated, of course. The dry explanation, the definition of an index from Wikipedia is that it's a data structure that improves the speed of data retrieval operations on a database table at the cost of additional writes and storage to maintain that index. So without an index, the database has to, and so, why would we need to look through? Why doesn't the database put it in order? The database is just not going to do that. It's not very efficient in the way that things write physically on the database. There's not really any way to put it in order, because if you try to do that, then you would have to reorganize the table almost every time you added a record. But if you do insert records in a particular order, it only goes in one order, right? So if you have everything ordered by last name, for example, in an employee table, what if you needed it by first name or by the city that they lived in? You would still have to sort it somehow. So putting it in a specific order, not very helpful except for one specific use case. So an index is a subset of the columns in the table, which those indexes can be sorted, and they point to the row that's on the table. So you put your index on column A, B, C, and column A is like descending or something like that. So when a query comes in for that particular, you send it in and it matches that index, all it has to do is zoom down that index really fast and find the pointer to that record in the table. So there's two parts. It looks for the record in the index, and then it goes to the table to get the rest of the columns that you want. So an example for an index would be your employee table. Quickly, like I said before, when you ask the database to insert records into the table, it puts it in there anywhere it wants. So if you had a grid or a spreadsheet that you wanted to put into the database, it's going to put it in maybe in the order that you sent it, but the database might decide to put it in some other order, but you don't know. But let's say it does put it in some order. That when it gets through the first 500 records, it's going to add the last 500 in on top of those, and then it gets all mixed up. Regardless, the data is not going to be in any order that you want. That's why you have an index, is because you don't know how the data is going to be inserted. And when you go on and you delete a record, it leaves a little bit of space in that table and also in the index side. And that space is going to sit out there unless you do some other kind of operation like a reorganization of the table. And if you add a record to that table, it could add that record to the bottom somewhere. So the index, the table insert and update operations, or the insert operations, may not insert into available space. It could just put it right down on the bottom. So the index is going to be pointing to the correct spot for whatever sort order that you want. So when it's doing all this, you're probably wondering what the criteria is, and that's complicated. It's kind of a black box inside those query optimizers, but it may just decide that, if there's physical disks, that it's going to insert it at this position because the write heads were closer to an empty space. It's just going to put it there. And it's just the efficiency of the operation is some of that in memory right now, and I'm put it in that way. And you really can't know exactly how it's going to do, but you can kind of make some assumptions. So let's talk about some things that people think about index. What do they think about indexes? So these are some of the myths. So indexes always make things faster. I bet you know the answer that I'm going to give you, and that answer is no. The key here is always. I mean, yes, they can make performance better, but if they're well thought out only. If, unfortunately, an index might do nothing at all, or it might make it worse. So I've seen a lot of people's first reaction when they have a performance issue. It's like, let's add an index. That's got to make it faster. And really, adding an index should be the end result of an analysis to determine the best course of action, rather than the very first step. So is the process running because of a missing index, or maybe the query is not written correctly, or the application is doing something that's not related to the database that just happens to be part of it? It could also be bad application code. Maybe somebody has just not used an indexed column when they could have. Ad hoc reporting is a good example of using indexes badly. When you leave a reporting tool to end users and they want to get certain columns, they're not always going to be aware of indexed columns or what's the most efficient way to do it, all they're going to see is that the report is running really, really slow, but this other report runs really, really fast. I don't know why. We must need an index. So when you get that feeling like things are running slow, let's add an index. Take a step back and try to, and definitely engage the DBA, because a DBA is going to be able to look at the query coming in, look at the indexes it's trying to hit, and give you the advice of how to make it faster. It may not always be an index. So there's other things that make your application process slower, like if you have something in there that is a not in condition, like A does not equal this value, like A doesn't equal 22. Well, it has to look through the whole table to find everything that doesn't equal that, because there's not a pointer that shows something that doesn't equal something. So you're going to scan the whole table. Adding an index adds performance. Just don't add indexes based on what you see. Here's another thing. In JD Edwards, if you're looking at your query, if you're doing an application query and using the QBE line where you put in your stuff and you hit send or you hit find, it goes out and sends that SQL statement, and it runs slow. One thing that you probably aren't seeing in the background is that if you have JDE security, that adds on a whole bunch of clauses to the where clause in the SQL statement to limit what you're going to bring back. So every time you submit the SQL statement, you may be only looking for account name, account number, and so on and so forth. But what you don't see, that you're being limited by business unit, for example, and that changes the SQL statement that goes to the database. And every SQL statement, even the most insignificant change, an extra space, an extra uppercase letter versus lowercase letter, as far as the database is concerned, that's a totally different SQL statement. So you need to grab that SQL statement. JD Edwards, you can get that from the logs, the debug logs, or you can ask a DBA to watch transactions as they go through the database. So when you don't need an index, here's an example of when you don't need an index. Right here on the table that we're using, we have an index on columns A, B, C, and D. Now your report only needs columns A and B in order to get the data. Now I don't have an index on just columns A and B. Let's create an index for that. And then you run it, and it runs exactly as slow as it did before. So why is that? It's because you already have an index on column A and B. It just also has column C and D. The database will always use a partial index if it can. Of your query, because it will still use the indexes that are already built there that have those columns. The latest database versions can even combine columns and use indexes from other indexes that are not exact. They're not contiguous. Like here, let me show you. Here's an example. So we have two indexes, one with column A and B and column C and D. It'll combine those indexes in order to find the data that you want if you're searching on A, B, C, and D. Now that's not as efficient as having an index with all four columns in one, but the database is still pretty fast and can get that through there. So you may not necessarily need to add an index for something that occasionally runs that needs all four columns. Because do you want to have all those extra writes go in there for this query you may run once a month? Probably not. So this is where it effectively creates the combined index logically. So if you have more indexes than you need, what's the big deal? And I've mentioned this a couple times already. It's because every additional index causes another write or a delete or an insert update, and that can be a big deal when you have a big table with a lot of activity and a lot of indexes. So in a small table like the FO114, it's got 4 columns and 1 index, and that's it. But if we look at the FO911, that thing it's got hundreds of columns. I don't know exactly how many, but comes with 36 indexes in 9.2. That means every single insert and this is on one of the most frequently accessed largest tables in the system. So that does add a measurable performance impact. So you definitely want to think twice, 3 times, maybe 4 times before you add an index to something like the F0911, because it may not work. It may not do anything for you except slow it down a little bit. Reports going to this tables like this are better written with the existing indexes in mind rather than trying to create new ones to cover some edge cases. All right, the next question is, more columns in an index is better. So when you make a column, should you include as many columns as necessary? Not really. Once you get past 7 or 8 columns, you're not getting much benefit at all. So and I just kind of guesstimated these numbers based on some of the things I've researched. So this isn't exactly what it would be in real life. But your first index, your first column in your first index is going to narrow down to hopefully a small set of records. If it's not, then it's going to go to the next index column, and it's going to narrow it down even further. Then the third index. But as you start to get to the 5th or 6th indexed column, the database may have already found the record and never gone on to the 6th, 7th, and 8th index. It just isn't necessary for, there might not be like you have 1 million records in your table, but once you narrow it down to the 4th level, there's no more narrowing that needs to be done. So you just have extra columns in an index for no reason. That also adds a performance hit. So if you're looking at a where clause that has 8, like where this equals this, where this equals that, and blah, 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 and you have 8 of those, and there is an index that covers the first 5 columns, then just go with that. Don't create a new, bigger index because you probably don't need it. And it takes a lot longer to scan through a wide index, so you want to keep those numbers down as much as possible. Should I generate indexes using the application? I think if you've probably seen the trend here with this presentation, the answer is going to be no. Let's go back. Let's go forward. Yeah, the answer is no. What happens is, this example is specific to JD Edwards. I'm not sure how many other applications allow you to generate indexes from within or do any kind of database operations. But this button here in JD Edwards, the generate indexes, when you click that, the very first thing it does is drop every index. It's done. As far as JD Edwards is concerned, the index regeneration was a success, even though it hasn't gone on to the second step yet. Then the next thing is it looks at the JDE specs for the indexes on the table, and then it issues a SQL command to the database to generate those indexes to build those indexes fresh from scratch. It's very similar to rebuilding indexes on a standard edition database, and even if you're on an enterprise edition database and you don't specify the online option, it just generates it in an offline method, and this is a huge mistake. I've made a huge mistake. So when it drops all those indexes, all of a sudden you have no indexes. Not only that, it locks the table for as long as it takes to generate all of the indexes. So that, as an example, if on 11 with its 36 indexes and millions of rows, your entire application will stop working until all of those indexes are generated. And if you have 300 million records in your F0911, so you're having to generate 300 million records for all 36 indexes that you have on there. And 300 million records, I don't know how many big companies there are in here, but that's not atypical for a large company's F0911. If you don't have table compression, or not using some kind of partitioning, and you do an offline index generation like this, It's going to take you about 24 hours to generate all the indexes. You can read it also generates, it will generate a single index on a single table. Still, the rule applies that it locks the table for the duration of this index generation, so that table will not be usable while you are generating. So a single index on the F111 might take 45 minutes to an hour. So if you can afford to be down that long, fine, but there are better ways to do it. You're probably wondering, how do I do it if I don't do the application? You create the index directly on the database. And it's very easy. You're going to be issuing essentially the same exact SQL command manually that JD Edwards would have sent. The cool thing is, if you're on Enterprise Edition, you can submit it as an online operation. That way, the index gets generated. The table doesn't get locked except for like a microsecond at the beginning and the end, and nobody's impacted by any kind of an outage. So what you do is you open a tool like SQL Developer, or on SQL Server, you use SSMS. You make the index changes directly in the database. And here's a create index dialog for SQL Developer. And then you put it on there, and you can do some testing, see if it actually runs correctly, if it goes faster. If it works, then you're good. You now have the index on the database, and JD Edwards is running fine. So at this point, you might be wondering, how does the application know the index is there if you don't create them in the application first? And the truth is that the application doesn't know or care what indexes are on the database. Now, you might care, and the application doesn't care unless you force it to, which you can't do in JD Edwards. So in JD Edwards, behind the scenes, E1 simply issues SQL statements to the database without any regard for indexing. Generally, only developers and admins are going to need index specs inside E1 just to facilitate development. Those aren't needed on the database. So the transactions flowing out of E1 to the database don't look at index specs inside JDE at all. When a transaction arrives at the database, it looks at it, decides what index it's going to use, if it uses one at all, and then executes the statement in whatever way it thinks best. It has no relation to what's defined inside JD Edwards. Another limitation of generating applications outside of the database, and using JD Edwards as an example, is you cannot create anything that's not like a standard basic index. If you need a special kind of index, like a function-based index, a sorted index, a bitmap index, something with included columns like on SQL Server, then you can only build those on the database. In Enterprise One, once you have created this index on the database and it's working for you and it's doing everything really well, definitely go back inside JD Edwards and create that new index, so that the specs are there. If you're going to need those specifications for updates, upgrades. Whenever you're doing new development, you're going to need to have those there for your fetch and your selects and things like that. Other administrators and developers are going to have that information there. And even if it's a special index that can't be created by JD Edwards, you still want to have that placeholder in there so that somewhere it's recorded. I mean, as a good development log is going to have that information in there. But if you see on your JDE specs that there's these custom indexes, then you'll know, wait a second, we need to create that on the database. And one tip for creating sequentially, take that index numbering out a ways, change the name a little bit to make it look obvious that these are custom indexes. And I'll explain that in a little bit towards the end of the presentation. So by creating these indexes manually on the database, you save a huge amount of time, because the index creation doesn't have to go through the JDE development cycle, and you can test the indexes immediately. And if you create an index and it doesn't do what you thought, you just remove it and try another one, and you don't have to go back through the development cycle again. So the next question is, can my report force the database to use a specific index? And I've already actually answered this question prior to this slide? And the answer is no. Not all applications or reporting tools allow you to send index hints, is what they are, and JDE is one of those. And even if you could send an index hint, you really wouldn't want like the one you're hinting and saying you use this one. It's tuned up perfectly for your application for this query right now. But what happens when more data is added to the table? What happens when the table statistics change? When you update maybe you upgrade the database and the way the query optimizer works changes. Eventually, the index that you're using may not be the best one for the job, but the database is going to have to use it anyway. So once you tell the database, use this index under every circumstance, it's still going to try to use it every time. It will override you in some instances, which is not in the scope of this presentation. But the bottom line is, don't try to second guess the database optimizer for your stuff. Now this here is a JDE development tool. When you develop a JDE application, you have to associate your fetches and indexes with ones that exist on the table. So this is for you developers out there. So I've run into some people that thought that since they had to pick an index to create the table IO named event rules, that the database would use that index specifically. And it won't. Also, if the developer doesn't see an index that they like, they just create a new one that looked better. Unfortunately, as I have already talked about in that previous part of the presentation, indexes just don't work that way. When like I said before, when JDE sends a SQL statement to the database, it's the database that decides what index to use. It doesn't matter what you choose in your table IO or what extra indexes you have defined in JDE. You can regenerate those indexes all you want, create them, whatever you want to do, but it's not going to affect how the database uses the index. So with this approach to indexes where you create random indexes all the time to support some development or these anything that is not based on looking at some of them are all probably really similar to other indexes on the database already that you could have used in the first place. And then, you're just adding all these extra rights and things. So you don't want to do this kind of just adding indexes because you need one to develop this part of the app. Try very hard to use the indexes that already exist. If you have to create an index in order to do a specific kind of fetch, consider maybe not creating that index inside the database. If it's just there to facilitate the development, but not necessarily in the database, then there's no reason to create it. So how do we handle these unnecessary indexes? And I say, kill all indexes. And that's right. Every index, any index in there is fair game for getting rid of it. What about the indexes with JD Edwards? These are not sacred. You will have to go into the app and remove them from the table specs, just like as if you were going to add a custom index, because you don't want someone to go in and regenerate an index you got rid of. You'll get all those indexes back. So what is the impact of unused indexes? So this is results of a query I ran on a SQL Server database that shows index reads and writes, and I sorted the reads by the writes from descending, so the most writes to show what is the 0 reads. So these are the top 50 tables. I kind of shrunk it down so it would fit on the slide, and then me too. So in these 50 tables, there were 0 reads on these indexes, but 640 million writes. And in this same installation, I added up all of the indexes with 10 reads or less, and that was almost 1 billion writes to those indexes. So you see that kind of thing in software that's been around for a long time, decades, or that were designed for kind of OLTP and reporting and data warehousing all in one application. And that's what JD Edwards is. It's kind of a hybrid OLTP data warehouse. So they overloaded it with indexes because all of the primary reporting is coming from inside JD Edwards. In an OLTP database, online transaction processing, you want to have as few indexes as possible so that you can have a much faster processing time. In a data warehouse, there aren't very many writes, so it doesn't matter how many indexes you have because you're just reading from it. You can have as many indexes on those databases as you want. It doesn't affect the performance. a million indexes on a table is going to speed up the reporting database, but it's going to destroy the performance of the application part. So that's when I make recommendations to large companies with a lot of processing. I always recommend make a reporting server where you can replicate your data to this other server, and then you don't have to worry about all the indexes that you need to make your reports faster. I told you I was going to touch on custom indexes with application upgrades. If you upgrade or update your application, it may change table structures, it may change indexes. You're probably going to have to do some kind of custom maintenance. In JD Edwards, if an index is added by Oracle, then the index IDs are shifted around. So inside JDE, when an index is created in a table, they're created with an index ID value. And this ID value is created sequentially with each new index. And this index ID, you can look at it by looking at the TAM specs. It's not something that you're going to see in the application. So if a customer creates a new index on an E1 table, then a new index on the same table with the same ID is delivered in an ESU, then the E upgrade process is going to replace the custom index with the new index, and then push the custom index down in the ID numbers. So these custom indexes will be renumbered with a new higher ID, and this will impact table IO statements that are based on that index, because those are keyed on the index ID, and this has to do with development. So just something to think about when you go into upgrade. See where your indexes shift to, see how it affects your an index really is the solution. If you've done your homework, there's no good way to change the application without sacrificing the output. You've looked at what you've got, and you've determined that this query is going to be run many, many times throughout the day, and the index is going to save a lot of time and money. So what we learned today is if you want to generate a new index, you can create it in Enterprise One if you want to, but put it on the database first. Create it using the database tools on the database, and just see if it works for you, and just test that it's going to be in there. If you decide that you just want to do it within JD Edwards, it's a small table, tiny index, then just hit generate indexes. It's not going to, a really tiny table with 1,000 records and 4 indexes is going to generate in moments. But if you look at the index and you think, it's going to be a lot faster if I have included columns, or if I do a calculation in the index that produces a specific result that's not in the table, then those are custom indexes that can't be created by JD Edwards. You'll have to do that on the database directly. Then you're either going to do it through the application or through the SQL Developer or SSMS. If you have an enterprise edition of the database, you can create the indexes online. If not, any index generation, regardless of whether you do it with JDE or with the database, it's going to be an offline operation. So in that case, it may not really matter if you do it either way, depending on how your maintenance windows go. Now, there's some things that I haven't mentioned. There's a lot of new functionality and new features out there. If you're running on the Oracle Exadata, for example, so this is either a supercluster, Exadata, or engineered system, they use storage indexes, which are kind of similar to iSeries SQL packages. So these databases, the storage indexes, are kind of indexes created on the fly. It watches how the processing goes and then creates a storage index that manages these crazy statements that come from out of nowhere. SQL 2014 has a new optimizer that's also in 2016, 2017, 2019 that kind of does the same thing, where it actively looks at the statements and makes sure they can run faster. It tries to make things run faster without you having to manage it directly. Also, the Oracle optimizer in 12c, 12.1, and a little bit more granular in 12.2 has a similar thing. It's adaptive query optimization, which is pretty cool. Like everything else, it monitors the indexes and tries to make them work just right. I'm kind of on the fence to whether that's going to be as good as creating specific indexes for an application, but if you occasionally have weird things come in there that don't make sense or don't get run all the time, the database is probably going to execute that as well as it possibly can without you having to create a new index. And that is it for today. Thank you very much for attending, and I'm going to turn this back over to Brooke.
Awesome.
In just a moment here. You got it?
Yep, I got it. Thank you so much, Bill. I appreciate it. That was great. All right. So before we get into our questions and answers, I just want to cover a few follow-up items. Today's webcast is part of GSI's free ongoing educational webcast series on JD Edwards. And our upcoming webcasts are currently listed on the screen, but we are always adding more every day. So to view our most up-to-date schedule, you can just visit the link at the bottom of the screen. And we provide free, extensive educational resources for the JD Edwards community, including our weekly educational webcasts, our monthly newsletter called the GSI Insider, our online resource center where you can access on-demand webcasts, white papers, and so much more. And we also host on-site and virtual workshops. Now, if you'd like to go sign up for any of our email reminders for our upcoming webcasts or our newsletter, or to create an account, you can go to our resource center. Just go to getgsi.com, select resources and events, and then you can select the appropriate platform. All right, so Bill, I see we have a couple of questions. Oh, I'm sorry. We also would like to just let you know about erptalk.com. It is a collaborative forum, so you can go on there and ask questions and get your questions answered, as well as contribute and answer other questions that are on the forum as well. So you just go to erp-talk.com. Okay, so, all right, Bill, are you ready?
I'm ready.
All right, our first question is from Cameron, and he said, including clustered primary keys.
Yeah, I think this is related to dropping indexes. No, you don't want to drop the primary key. I should have mentioned that. All the JDE tables are going to need at least that one primary key. So you really want to be looking at tables that have 10, 20, 30 indexes on them. So yeah, leave the clustered primary keys alone.
Okay, great. All right, next question is from Stacy, and Stacy says, does the methodology that you explained on how indexes are used and determined true for all database platforms, including Oracle, SQL Server, DB2, or is it specific to the Oracle database platform?
This is going to be for all relational databases. So Oracle, SQL Server, DB2 UDB, DB2 400. They all use indexes the same way. You know, the iSeries is a little bit different animal, but it still uses indexes. So this applies to all of those. That's correct.
Okay, great. Perfect. Thank you. And we have one more question from Helen, and she said, do you recommend scheduled re-indexing maintenance?
That's a very interesting topic, subject of much debate in the database world. I do not think that reindexing is that necessary. If you have the spare time and you can afford to have some downtime, you know, if you have a maintenance window where this can be done without impacting your users, then, you know, sure, why not? But with modern SANs and storage and databases, those reindexing and rebuilding indexes and things like that, they're not as necessary. It's getting to the point where it's just busy work. I'm not saying don't ever do this stuff, but you know, when you especially if you're virtualized and you're using virtual storage, that storage is already kind of fragmented by its nature, and the virtual storage handles this fragmentation as part of how it works. So when you go in and like defragment an index, for example, is it really being defragmented, or is it just putting it in different parts of an already fragmented storage system? This stuff made a lot more sense when it was physical disks running directly on your SQL Server or your Oracle database. It doesn't have the same effect on modern systems. So I guess to summarize, if you have the time, the downtime, it's not going to hurt anything. I would say to try to do some baselining and see if you experience better performance after doing this. And if you're not noticing very much changes, then I would say you can probably lose that from your maintenance schedule.
Okay, great. Thank you so much, Bill. All right. Well, that appears to be the end of our questions for today. And I want to thank everybody for your questions and Bill for your answers as well as your presentation. And as a follow-up from today's webcast, we ask that you complete a short 1-minute survey when you exit, and you will be receiving an email with a link to our Resource Center on our website, where you can access the recording from today's webcast as well as a copy of the presentation. And after today's webcast, we will do the drawing for the $25 Amazon gift card, and anyone that attended the entire webcast will be eligible, and we will notify the winner. And if you have any follow-up questions, please do not hesitate to contact Bill or myself, and we will make sure that we will get back to you. And our contact info is currently listed on the screen. And again, I'd like to thank all of you for attending today, and Bill for your great presentation, and we hope that you have a great day.
Thanks, everybody.
Thanks.